Okay, first of all, thank you all for coming. I hope you're enjoying GeeCON so far. This is the last slot of the day, so I'm going to assume you're all fully caffeinated and yet extremely tired. So I'm going to try not to bore you too much, but, if I am boring you, then you can always just throw stuff at me. That's a dead giveaway that I should pick up the pace. So, the title of this talk is Non-deterministic Software for the Rest of Us, and I'm going to have to spend about 5 to 10 minutes explaining what the hell I mean by that. But to start off with, my name is Tomer. This is my fourth GeeCON and third in Krakow, probably my favorite conference. So let's get started. Just one point of order. There's the link to the slides above, so if for some reason you want to follow along or turn back, then you can. All right. So we're going to be focusing on 2 case studies, and it's going to be, I hope, very, very clear what I'm aiming at here. But I want to take you back roughly 11 years to 2007, a little startup called Delver that I used to work in and eventually became Sears Israel for some reason. We built a search engine, right? Fundamentally, that was the product. It was a full-blown search engine. Now, it had its own interesting aspects. I'm pretty sure it's still kind of the world's first social graph-driven search engine. But whatever the case, the question remains, what makes a good search engine, right? What are your expectations from a search engine back in 2007? Really, there's 3, right? It needs to be quick, because Google showed everyone that you don't have to wait for like 10 seconds for Lycos or Alta Vista to not give you the results you want. It needs to be reliable, by which I mean it needs to actually work, and it needs to be useful, by which I mean that you expect to actually find results that are meaningful to you when you perform a search. So we got started back in 2007. We put together a team, put together a group, applied some good old-fashioned software engineering, right? So we wrote tests, we built the whole thing. It was really TDD. TDD wasn't a very well-known concept back then. But we did have a very large test corpus. We actually invested a lot in like code quality, linting tools, just what have you, right? We really tried to write code the right way. And it was actually kind of great. So this was probably my first kind of large-scale project with a substantially large test corpus. And out of that, we got reliability. Like, we caught a lot of bugs that we would have otherwise caught in production. We had fast iteration cycles. We had a built-in sort of regression suite. So things that worked generally tended to continue working well. And yeah, we coded the thing, right? We had a full-blown search engine up and running in about a year. It kind of worked, right? Kind of. It was highly available. It worked. It responded within SLA, so it was fast enough. But the results were crap, right? Fundamentally, the quality of results you got from this search engine was just not good enough. We're just getting started. We weren't really worried about it yet. We're still trying to figure out what building a search engine actually means. But fundamentally, crap results plus tests tells us one thing, which is if you have a bunch of tests and they're all green, unit tests, integration tests, what have you tests, they all come out green for a particular software version, it doesn't mean much, right? For certain classes of software, just having acceptance tests of any sort and making them run is just not good enough. So it turns out that not all software can be acceptance tested. So if you think about it, there's at least 3 categories of software. Anything that's fundamentally subjective, so like search results for one, but your newsfeed, right, on Twitter or on Facebook, these things are ordered in a way that's designed to make you engage with the platform more, right? There is no objective definition to what the right order for things in your Facebook feed is. It's something that Facebook keeps playing with so that you feel happier, right? You have more reasons to interact with other people based on their platform, and they're happier because they get to show you more ads and win more money, right? But fundamentally, you cannot have just acceptance criteria for it because, like, what test are you going to write that tells you that a news feed is a good one? Another category would be one with, like, huge input space. This is a screenshot from some guy who actually used the Hot Dog or Not app that Silicon Valley put together a few years back. And I really love this picture because it showcases everything that is wrong with the tech scene in Silicon Valley. But regardless, fundamentally, you cannot feed every conceivable input into a system. You cannot test it on any conceivable input, right? It's just impossible. So it turns out that with these types of systems, just having green tests is not good enough either. And finally, you have things like Uber or Lyft as examples of something that is fundamentally resource constrained, right? Whatever the case, the system working means that if there are available cars and me as a client called a taxi in or called an Uber in, then I get an Uber. That's working for Uber. But everything else around, does it select the right car? Does it optimize for cost? Does it optimize to improve the driver's experience or the user's experience? All of these things are things you cannot test for. Or rather, you cannot test for in the TDD sense. You cannot test for them ahead of time. You cannot write a test suite that just runs in your build and showcases all of the things that are potentially wrong with your system. Right? You just can't have acceptance tests for these things. By the way, if there are any questions or comments, feel free to raise your hand. If I notice you, I will pause. There is no problem. Right. So the first takeaway from this talk, just to give you some idea of what it is we're going to be talking about. Correct and good are two completely separate things, right? Think about Google, right? If you type in a search query into Google, you might get amazing results, but if Google would have failed as in showed you an error about half the time, you wouldn't use it. So it's correct, or rather, it's good. It gives you good results, but the system is not correct. It's broken, right? It's totally unusable. So these are problems. On the other hand, if Google today would always work, always give you sub-second results every single time, but the results were crap, you wouldn't use it either. So you need to have both. And for some classes of software systems, like the ones we just showcased, correct and good are things you have to measure separately, treat separately, and you need both. Okay. When I say non-deterministic software, what I mean is any piece of software where the criteria for correct and the criteria for good are not the same. As with Google, search results are good is one thing, working is another thing. Right? So how good is the system is not good or bad. It's a whole spectrum of possible answers to that question. It's non-binary. Right. For any given product, product feature, full-blown product suite, whatever it is you're working on, but for any given product, you always should be asking two questions. The first question you need to ask is, what does success look like? Right? This is, you might have run into some variation of this. This is actually based on a Japanese game show, or one part of a Japanese game show called Brainwall. But success is when the user is happy. The other question you need to ask, once you understand what success is for your particular product, you also need to ask, how can I measure it? Right? So for instance, in the case of Brainwall, you can have a very simple metric for success. Is the person wet or not? If the person is wet, they have not succeeded. If the person is dry, they will have succeeded. It's a very easy product to analyze. But for your own product, be it a search engine or an Uber app or whatever it is that you're working on, you always need to be able to answer those two questions. What is success? How do I measure it? Finally, you're an engineer. Presumably, the vast majority of you are software engineers, right? And I stress the word engineer intentionally, right? What we do here is we build stuff that's rooted in science. Intuition doesn't work. Intuition is bogus. So just to give you an anecdote, we had a product at the company that up until recently I worked in. It did have some sort of recommendation engine in it. We had an implementation of it that was running in production, and we all knew that it was initial and it wasn't good enough. So we re-implemented it based on a completely different software stack, but same interfaces, same user experience, same everything. Right? It was just supposed to be better. We had 10 people, product management, QA, a bunch of engineers, like a couple of just random people come in, say, oh, sure, this looks way better. When we put it in production, it dropped user conversion by half. So it wasn't just not better, it was catastrophic. So intuition doesn't mean crap in this business. And if you're going to say, well, that's what I have QA people for, well, QA can't really save your butt. Right? I mean, if you call in like a manual test engineer and say, rank how good this feature is, or here's a new version of this feature, is it better or worse? They're not any more qualified to give you an answer than you are. Right? They're still going to base their answer on anecdotal evidence and intuition. And when it comes to software engineering, there is no substitute for data. So take your intuition, drop it on the floor, doesn't mean anything yet. So what should you measure, right? If intuition isn't good enough and you need some sort of viable mathematical means of determining whether your software is better or worse than it was yesterday, then you need to measure something. Now, fortunately or unfortunately, depending on how you look at it and where you are on the tech support spectrum, you have customers, right? Presumably you have customers. And you can actually look at what they do. You can actually analyze their behavior in order to answer those two questions, which are, what is success and how do you measure it? So for a search engine, for instance, what does a user do? They type in a query, they get a bunch of results, they skim the results. Like, what do you do when you type something into Google? Right? You type it in, you look really, really fast at the first page of results. If you see something valuable, you decide to follow it. Right? You just click on it. But then maybe you don't see something useful, but the results seem roughly consistent with what you had in mind, so you might page, right? You might ask for the next 10 results and the next. Or you might say, well, this is kind of what I meant, but actually I might need to add a bit of information, right? I might need to, say, disambiguate something. If you're working with Apache Camel and you type in camel into Google, Google doesn't necessarily know whether you're talking about Apache Camel or the really ugly, by the way, animal that is very common in Africa and the Middle East, right? So you might need to disambiguate it. You might need to add camel software, camel Java, whatever it is you do, you refine your query so that the search engine has some better context on what it is that you mean. Now, time for takeaway number 2. If you actually want to be able to do anything useful for your users, you need to start taking into account that for a lot of systems, users are a part of the system. By which I mean your users are not just people making use of your system. A lot of the time, their interaction with your backend, like with your service, those two things put together comprise the system as a whole. And the search engine is a canonical example of this. So, let's have a look at the same graph. We have 3 signals just on this very, very, very broad definition of what the product does. Right? A user might page to the next page of results. They might refine their query. They might follow a link. All of these things are signals that we can take into account in order to measure the success of the product. Paging means the results are meaningful but not relevant enough. I'm going to look for something a little bit deeper. So that is a sort of a mixed signal. It's like, okay, you're on the right track, but you haven't succeeded yet. Then you have refinement, which means I don't care about what you're showing me. It's not relevant. I need to add more data. Click-through is success, right? If a user clicked a link, that is success. Clicked on a search result, of course. And you can even sort of refine that further by treating the rank of the search result that the user clicked in on just how very successful were you. If they click on the first result, that's best. If they click on the 7th result, maybe you need to improve your search algorithms, right? So that's a signal you can actually use. And then there's a bonus signal, where if they don't actually pick any of these, then that's also a signal. Like if a user comes in, types a query, and then just closes the tab after 3 seconds, that is a signal. It is a very ambiguous signal. Maybe they just had to go or something. But in the aggregate, it's a good indicator that you have failed, that the search results from your search engine are not good enough. Now, we'll circle back to this in a second, but I want you to not treat search engines as sort of the thing I'm talking about. It's just an example, and I'm going to follow this up with another one so you can see that the mindset is what's important. Now, all of this discussion, please raise your hand. Does this look familiar to you? Have you had these types of discussions before? Okay, about 20% of you, fewer than I expected, to be honest. But for the rest of you, this should still feel a little bit familiar, because it is. We call it BI, right? We've been having this conversation with our product managers and business analysts and data engineers and our CEOs and our stakeholders for years. But if you look at sort of that round thing, which is the product change iteration, if you will, a product manager comes in and says, I want to change in this product. They hand off, presumably a spec, but whatever. They hand it off to R&D. The R&D department makes the change and deploys it. And then you have some sort of measurement in production and business analysis, and then that informs the subsequent product changes. So all of these things on the left side of that circle are informed by BI events, except R&D. The point I'm trying to make here is that for some classes of software that you might be working on or that you might end up working on, you actually need to be informed by user interaction. You need to track these things. This is not just a product manager level discussion. These are things that you can take into account when you engineer your systems. What can we learn from it? So BI is really about three things: analysis, experimentation, and iteration. With regard to analysis, always be mindful of your users. If you don't know what it is your users intend to do, you have no chance in hell of defining what success looks like or measuring it. You will have no idea whether the next iteration, the next version, the next whatever sprint of your software will actually be better or worse than the previous one. Once again, this is not true for all types of software, like line of business things that can be fully specified generally do not fall into this trap. But a lot of the sort of things that we do on the web nowadays does. So be mindful of your users. Try to think in terms of what is success for my end user. And the end user doesn't have to be the tech unsavvy person trying to buy shoes on an online store. It might be an engineer working against your API. You always have users. It might be the tech support guy in your company working against your reports. Right? There's always an end user, otherwise your software has no reason to exist. So be mindful of your users, and actually you might have a very good resource in your company to start making sense of these things, and that's business analysts. Now, pro tip, if you have business analysts in your company, and you as a software engineer approach one of them and say, hey, I need your expertise. Would you mind sitting with me on this new feature that we're setting up and helping me understand what matters to the user? They're going to be so floored by the fact that anyone from the engineering department proactively came to talk to them. They're going to do everything for you, right? So talk to them. They'll be helpful. Experimentation. If you want to be able to say whether a software change has improved or reduced quality, then you need to be able to experiment, right? You can't just go wholesale. You need to be able to say, this group of people are using the old version, this group of people are using the new version, and this is the subsequent change, right? These are the ramifications. So you need to invest in an experimentation infrastructure. And there's a lot of options there. The company I recently left, Wix, actually has an open source experimentation framework called Petri you might want to look into. But regardless of how you do it, you should be able to actually have data coming in from two separate groups of users and contrast and compare. And once again, this is not about your product managers. This is about your software system. Secondly, you need to prove that whatever it is you did actually caused an improvement. If you're working on a search engine and you've made some improvement, you took more fields or more signals into account, you need to be able to run an experiment and prove that that moved the needle, that your customer success is actually higher. And finally, iteration. So one important thing is a lot of engineers, myself included, by the way, this is not bread and butter for me. I used to write line of business software for 10 years before I started on these types of projects. A lot of the confusion and fear circles around, but what do the numbers mean? What am I supposed to read? How am I supposed to read these numbers? And actually, the numbers themselves, for whatever it is that you're measuring, the numbers typically don't matter. It's the change that matters. You want an improvement trend. You don't care that for whatever metric it moved from 4.7 to 4.8, right? The number in of itself is meaningless. But you need to know the baseline behavior of your system for anything that you measure, and then you can actually start talking in terms of improvement or regression. So once you've established a baseline, in order to actually make any meaningful work on your software, you need to have some sort of metric collection and dashboarding in place. If you don't have that, if you don't have some means of actually tracking what it is that you're measuring and charting it and showcasing it and storing it, then you're already doomed because you don't have the data you need to do your work properly. So these are things we can learn from BI. Now, the next takeaway is versions are kind of meaningless. We as software engineers, especially in line of business software, are used to thinking in terms of this build failed or this build succeeded, ship it, right? A version in a world of sort of continuous improvement where the success is not a binary, okay, I'm done, or okay, I have bugs, I need to continue working on this. Versions are meaningless. The only thing that matters is the experience of the end users working against your system. So you need to measure these things continuously. Irrespective of what changes come into your software, you need to ultimately be able to say, right now, for the version in production, we are 2% better in our success criteria than last week, right? You always need to be able to say that, and that does not necessarily tie to a version number. Moreover, a lot of the times, these acceptance metrics don't necessarily even revolve around your software. They might include third parties. They might include your users, and your users might just be having a bad hair day or something, right? So you need to look at these things continuously and in aggregate. Now, up until now, I've been talking about search engines and in very broad terms. What I want to do next is I want to tell you a little bit about a different software product and that I also worked on a few years after, where we, being myself and the rest of the members of the team, try to apply sort of the same methodology, the same mode of thinking, and have been somewhat successful. So this is actually a second kind of case study. 2011, I joined a small startup called New Brand Analytics. You will have never heard of this company. It folded. Actually, it was bought out, it was an acqui-hire after a couple of years. Nothing interesting. It didn't really succeed as a business. What is important, though, is that the product that we're constructing is inherently a strange one. Is one that actually was very hard for me as an engineer to get right. It took us a lot of attempts to sort of figure out a working model for how to run this as an engineering business. Now, what the product was is what's called a social listening platform. Fundamentally, our users were operational managers for small businesses. So for instance, if you're running a restaurant or a chain of restaurants and you have a number of locations, you want to be able to find user-generated content that relates to your business. So in the case of a restaurant, you would probably be interested in things like reviews on TripAdvisor, comments on Facebook, posts by people on Facebook referring to your business. All of these things are things you want to know as a manager of a particular branch of a particular restaurant. So what the platform does is it gets these reviews, it aggregates them, breaks them down, and gives you what we call operational analytics. So the idea is if there's suddenly an uptick in people complaining about the cleanliness of your bathrooms, right? If there's 3 reviews that came up in the last hour, then maybe you have a problem and you want to be notified about it, right? That was the business we were in. A product like that fundamentally revolves around 3 separate stages, and you don't really have to read the details. It's acquisition, by which I mean go out onto the global internet, find all of the relevant pieces of data, right, the reviews on TripAdvisor and OpenTable and whatnot, bring them in, like acquire the data, bring it in, do some analysis on the data, because, for instance, a Twitter post saying, the McDonald's at the airport is filthy today, right? That in of itself is not very useful. You need to actually break it down into something structured so that you can aggregate and actually offer meaningful dashboards to customers. That has to do with text analysis and all sorts of stuff. We're not focusing on this, right? You bring in the review, you break it down, and then you aggregate and provide analytics over it. So it's a 3-stage pipeline. The team I was in focused on the data acquisition part, and there's a whole set of ways of getting at the data. Ideally, you will want to have some sort of business arrangement with, in this case, a TripAdvisor, so that they can actually hand off the reviews to you. But we were a small business. We didn't have sort of the gravitas it takes to actually go to TripAdvisor and say, hey, let's partner together on this. So as with many other sort of software projects at the time, we ended up doing web scraping. By which I mean we had robots or crawlers or scrapers, call them what you will. We had pieces of software that would kind of impersonate a user in a browser, go to the target website, do whatever it took, and then bring the data in. Now, imagine how you do this manually. You would go on to a particular link in TripAdvisor representing a restaurant. You would go review by review and just copy stuff over. Right? This is the author, this is the review, this is the number of helpful votes for this review. So this is structured data extraction off of an HTML site. And we needed to do this at scale, and more importantly, for our customers, the reliability of our data acquisition platform was of paramount importance, because if we're going to be showing operational guidelines for people, like if we tell a chain manager, look, compared to, like, with respect to your competitors, you have a real problem with cleanliness, and people are complaining about it. If we do that, and it's a mistake, then that's costly. It's costly to the customer, it's costly to us in terms of reputation, right? So we needed to actually be able to ascertain that the quality of the data that we operate on was very, very high. We would have to bring in all reviews, not have garbage data, not have duplicates, filter out like spam and crap like that. The data was really, really, really crucial to everything that happened after we brought it into the system. Now, it turns out that this is actually a very hard problem to solve, because target sites, and by target sites I mean sites like TripAdvisor and OpenTable and Yelp and like every sort of social review site that you'd care to mention. Well, to start with, since we don't have any kind of API-based integration with them, we actually scrape them. Like we issue HTTP requests, we get back an HTML, we read it into a DOM, we extract things from the DOM. Now, all of this is based on a site structure and layout that we have zero control over. So at any given time, indeed, at any given time, any one of these sites can just change on us, either subtly or completely. Like Twitter might roll out a completely new version of their UI that breaks everything we've done until that point, right? And that's something that's outside of our control. That's an extrinsic thing that can happen at any given time. Secondly, they don't really want us to scrape their data. Now, I'm gonna set aside the legal and moral questions surrounding whether or not web scraping is a legitimate business practice or not. But fundamentally, TripAdvisor is a company that thrives on their data. Their data, the data that you put into their systems, is proprietary data of theirs. Now, it's true that they post it publicly on links so that there's nothing to stop you from just going in and writing it down. It's kind of akin to walking down the street, seeing something in like an ad, and just copying it down. You're allowed to do that, right? But they don't want you to, especially not at scale. For various reasons, some of them actually very good. So this actually caused quite a bit of trouble and frustration for us. Now, both of these are external constraints, and you can't unit test either one of them. Does anyone here want to challenge the assertion that you cannot unit test something like a scraping script? No? Okay, I had this whole argument ready in my head. Okay, never mind. You cannot really unit test either one of these things. Once again, because they're outside of your control. Right? You don't really know what you're up against when you issue an HTTP request against Twitter. So, fundamentally, we applied the same methodology. Like, we tried to understand what success is and how to measure it so that we can actually have some way of monitoring and improving our product. At New Brand Analytics, fundamentally what users do is they consume reviews, whether individually or in aggregate through an analytics dashboard. Whatever the case, they consume reviews. That is what they do. Now, reviews come in from all types of sources through the data acquisition platform and are used for various types of user activities. What is success like for a user? What do they want, right? If they consume reviews that we offer them, then they want completeness. Like, they don't want there to be any missing reviews. We actually had customers calling in to us at first while we were kind of setting up and figuring things out, saying, look, I just visited the Yelp page for my restaurant, and I see a bunch of reviews that don't show up on the platform. What's up? So it turns out that completeness was a very, very important success criterion for our end users. Second is correctness. We had huge issues with duplicates and just garbage data that we would generate whenever sort of one of the target sites would change. So like our scrapers didn't have very good error handling to begin with, and they wouldn't sort of abort the process if they just came up with meaningless data. That was a huge problem for us. And the third is timeliness. Our users expected something akin to near real-time experience on our system. Like if a review was posted, and for some customers, if a review was posted on TripAdvisor and didn't show up in our platform within 10 or 15 minutes, we'd get a support call. Right? So these are the things that matter to users on that particular system. Now, from an engineering perspective, what can we do with it, right? How do we measure it? These are the things that determine whether or not our customers are happy with us. And we need to have some proactive way of telling whether we meet their expectations or not. So with completeness, really, if you want to determine whether or not your web scraper works and brings in all of the reviews, really there's only one of two things you can do. One option is to do it manually. Now, by manually, I mean you set someone up, say, okay, these are the results of the automatic scraping. Now, please go and verify them for me. This is very costly. This is very time-consuming. Humans are terrible at this sort of job, like just terrible. It's routine, it's mundane, it's boring as shit. No one wants to do it. If you get like a student or something willing to do it because the pay is good, they're going to get bored and start making mistakes in about half an hour. Right? This is not a tenable solution. It's actually kind of reminiscent of like data entry positions from 40, 50 years ago when you had human beings doing the work because computers just weren't like fast enough or useful enough then. This is a shit job. You don't want anyone to do it, and you certainly don't want to pay them to do that work. The other option, obviously, is you do it automatically. Now, this turns out to be quite difficult, and more importantly, this is one of those non-binary things. Like, you can't really say with full confidence, yes, my scraper works. And here's why. Two things. First of all, the data that you're expecting might change, right? Whether it's because the website in question actually changed their sort of data schema, now they're collecting more stuff, or they're not collecting things they used to collect before, or they have all the data, but they changed their UI, and now you can't get at the data. That is one thing that can change. But moreover, if you want to actually automatically verify things, like a human is very good at telling what's important and what isn't. One of the advantages of setting a human in front of this, going like, these are the results from this TripAdvisor run, this is the TripAdvisor link, please go have at it, tell me if this is good enough or not. Humans are actually very good at determining things like, well, the helpful vote count for this review has changed since yesterday, but who cares? That doesn't apply to whether or not your scraper is working, right? So those determinations a computer can do. A computer, like a machine, doesn't have the smarts to determine what's important and what isn't. That's what we're here for. So what we ended up doing is we ended up rerunning what we called the harvester back then, but fundamentally a scraper, right? We would take all of yesterday's results for a sample of businesses, rerun the scraper, like bring me all the reviews for yesterday, and compare them. And we'd make some shall we say, intelligent decisions around what data is allowed to change. Things like helpful counts, we just completely disregarded. But things like text differences actually matter. Because if there's a difference in text of one character, does that mean that the scraper broke down? Probably not. Maybe the review was edited. Maybe the site layout changed a little bit and you got that extra white space from the rendering engine on TripAdvisor's part. Right? So what we did was we calculated a similarity score. And by similarity score, this is not a mathematically proved construct, right? None of us had any sort of background in data sciences or math or, for that matter, computer sciences. We just winged it, right? We looked at the things, we took the edit distance of the text, we ignored a few fields, and we just put together a score. What that score meant was absolutely nothing. The number in of itself was meaningless. But since we had that number, we could chart it over time. And since the number was trivial enough to compute and trivial enough to look at, we could start seeing trends. And once we sort of worked out a reasonable sort of way to graph the changes, we could actually apply even the most rudimentary of anomaly detection systems like Anodot or Datadog or what have you, it doesn't really matter. Even the most trivial of these systems would actually catch the case where like a major shift has happened and suddenly the web scraper was failing completely. And we started getting these indications long before our users called us to complain that their data is crap. And that was a huge win for the company, right? And this is purely an engineering thing. This has nothing to do with product management. This is just us asking the question, what is success and how do we measure it? And this was one of the 3 success criteria that we had to tackle. Another success criteria is correctness. So completeness and correctness are actually things you can sort of apply the same mechanism for. Like if a review is missing, how can you tell? Well, you can tell by running the same scraper over the data from yesterday and finding out if there are any reviews that are suddenly gone or any new reviews that have popped up that you didn't expect, right? That's how you deal with completeness. Correctness has to do with the similarity score. It's the same mechanism. So just by doing this, we've managed to not completely eliminate, but we've managed to reduce the panic of having a scraper break down on us in the middle of the night from something that's a business risk, like our customers were getting antsy, like they weren't happy. We kept breaking, we kept missing reviews, because we just didn't know. Like they had to call us and let us know, which means they noticed. This allowed us to know ahead of time, to some degree of accuracy, whether or not our scrapers were successful. And that was a huge benefit to the product and the company. Now, the other part of the equation is, as I've said before, targets just do not want to be scraped. I love this picture, by the way. If you haven't seen the film UHF by Weird Al Yankovic, do it. Major sites like TripAdvisor, Facebook, Google Maps, Google Base, like a lot of these sites, especially the more important ones, the ones that you actually care about the data that's contained in them, employ a variety of techniques to actually stop you from scraping them. There's the obvious things like throttling by IP address. So if you start banging away at one of these sites, once again, no login, no API keys, no nothing. Just hit reload fast enough on your browser and you might run into throttling. That is a relatively easy blockage to deal with. You just route your traffic through a large span of IP addresses and you should be fine. The more difficult problem had to do with traffic fingerprinting. So especially Google got very, very, very sophisticated at figuring out that all of our crawler traffic comes from the same source and just blocking it off. We've found some ways to work around these techniques, but that's not the point I'm trying to make here. The point I'm trying to make here is that whatever set of solutions we ended up putting in place ended up being fairly expensive. This is not, in of itself, a tractable problem. You can't solve it easily. You can dump a whole bunch of money at it, and then you'll get some of the way there. But how does that apply to timeliness? Well, it turns out that this whole thing is an optimization problem. Like, if you don't have some sort of callback or like an API integration with your target website, how do you even know that there's a new review that you need to bring in? You need to actually run your scraper again and again and again at some frequency, and every time ask the question, bring me the latest review. Is this the one I already have? And if not, well, there's probably new reviews. You need to start sifting through the site, right? But this polling is expensive because you're throttled. Because in order to not be throttled, typically you'd have to go through like third-party proxy providers or VPN providers, and there's a cost associated with it. So fundamentally, the amount of traffic that you can generate, the amount of requests that you can issue against a source is limited, which means that this is not an engineering problem per se. This is an optimization problem. The question becomes, how do we provide the best service to customers given the constraints that we have? So this is a trade-off, right? And the trade-off was different per source. Like, certain sites would throttle much more aggressively than others. Certain sites were easier to work around. Certain sites we had to, send 10 requests in order to get at a review. Some other sites we'd send 1 request and get 10 reviews. Like, there's a whole lot of different things going on here. But once you start treating this as an optimization problem, you can actually start putting together some interesting solutions so that your customers are at least, either they're happier or at least they don't know that they're not happy. The way we dealt with that was we set up a cost model. Like, we tried to figure out what is the cost of bringing in a piece of user-generated content for any given source. And it's broken down by source. Like, if I have a restaurant and I'm bringing in a review from TripAdvisor, how much does it cost? There's a cost. It's simple. You need machines, you need bandwidth, you need third-party proxy providers, you need all of these things. You can put those numbers on an Excel sheet and figure out how much does it actually cost you to provide a service to your customer. Once you've done that, you can do 2 very interesting things. First of all, you can actually have an informed discussion around your pricing model, right? You can actually say, well, we can't really provide a better service for everyone, but not all of our customers care as much about timeliness. So we actually worked, like we as the engineering team put together the infrastructure and brought in the data. Then we sat together with the product manager and operations teams in our company, and we actually started putting together some sort of tiered pricing model where the customer actually cares about near real-time timeliness and we're willing to pay for it. We could give them better service. For customers that didn't, we could actually give them a much better service by allowing them to have more and more data sources that weren't pulled as often. But if you don't care whether your review shows up in 5 minutes or in 1 day, well, it turns out that we can actually provide you with a better service for a lower cost and at the same time use sort of the remaining budget, if you will, to give better service to a higher paying customer. So these are things you can start doing only when you ask the questions, when you ask those 2 leading questions, which are, what is success? How do I measure it? And without that mindset, without that going through that process, you're actually screwed because you have no way as an engineer of actually saying my system works. Like, your boss calls you in the middle of the night saying, look, I got off a call with a customer and they say it doesn't work for them. And you go and you try running it manually and it seems to work and say, I don't know what the problem is, it works fine. Except it doesn't because it works fine for you from your IP address, but actually if you do the same, like run the same workload on production servers, they're all blocked by a third-party provider, right? So if you don't go through this process of figuring out what it is that drives your quality of service, you can't, as a software engineer, put together the right solutions, the right infrastructure, the right measurement infrastructure, even the right feature set. Like, you will choose wrong. You won't know what's going on in your system, and you will never be able to provide a good service to your customers. Now, everything I've said so far is not true of all systems. Once again, if you're building something like an accounting system for a line of business type, well, enterprise, then you already know what success looks like. Success is not making mistakes. Success is if the accounting report that has to run daily or weekly or whatnot runs complete successfully and has the right data. And you can test that because there's nothing, like everything is deterministic. You know ahead of time what has to happen. For systems where the result comprises something beyond what you know ahead of time, it comprises user interaction or it comprises some resource allocation thing, the definition of good and the definition of correct start looking very, very distinct. And if you keep convincing yourself that you can determine good with the same tools that you determine correct, unit tests, acceptance tests, integration tests, smoke tests, whatnot tests, you're going to fail. And failing sucks. So, to recap, 3 takeaways. Correct and good are separate dimensions. Users are typically a part of your system. For some systems, it doesn't matter. For a lot of systems, it's critical because if you don't take that into account, if you try to measure the success of your users without taking the signals that your users provide for you into account, you're going to fail. And finally, systems are not snapshots. You need to measure continuously. Versions do not matter, especially when other factors can actually determine your quality of service. Once again, if TripAdvisor decides to block all traffic from your IP range, then the fact that you haven't had a release in a week and everything is stable doesn't matter one iota, right? These are things you have to do for problems where there is no easy definition of success, where a green test doesn't mean your user is happy. And there are a lot of systems like that, and especially today with machine learning models being more and more employed in sort of everyday work, machine vision, large-scale systems that become optimization problems, all of these things are becoming more and more commonplace. If you do not start thinking in those terms, in terms of what is success, how do I measure it, am I measuring it, am I improving, you're going to fail. And failing really, really sucks. And with that, I am done. If there are any questions, I'd be more than happy to take them. Okay, thank you very much. Enjoy the rest of the conference. Cheers.